Hello everyone, good morning and welcome to the class. Hope you all can see the screen. So today let's begin with another container orchestrator tool, Kubernetes. We have learned what a container orchestrator tool is, right? In this category, we are going to learn Kubernetes. This is the shortcut by removing 8 letters in between. That's a shortcut for Kubernetes. And we have learned Swarm yesterday, right? We understood what's a container orchestrator. It checks for high availability of the containers, load balancing of the containers on the cluster, scaling of the containers, rolling updates, rollbacks, all of that can be taken care by. So Kubernetes is under the same category, but which is very widely used because of its advanced features, right? And the robustness it offers. So let us look into the differences. Very basic differences we'll get started with between Swarm and Kubernetes. Yesterday I have mentioned few of them, right? This is a product from Docker and it can manage only Docker containers. This is initially a product of Google and now managed by CNCF, Cloud Native Computing Foundation. And it can manage containers from any runtime, right? Like a Rocket containers, LXC containers, all of that can be orchestrated. Okay, and Docker Swarm commands are just simply same as Docker commands, but this is a whole different tool. The learning curve is steep. And then you don't need to install Swarm separately, just you can do Swarm in it. You have to initialize it to get into the Swarm mode. But here the setup is again whole different setup. The setup varies from platform to platform. Like there is a different setup if you do it in on-prem, another kind of setup if you are doing it on a cloud. So the setup varies, but the concepts, the commands remain same, whether it is on-prem setup or on cloud or whatever it is, right? And Kubernetes cluster setup is complex of out of all the configurations we have done till now. But yeah, we doing it properly with all the steps uh, in a sequence or in a proper order without missing anything will help you uh, spin up your cluster quickly. And here you run all the commands in the imperative mode, right? Like you have all the CLI commands first one. Mostly we'll do everything with the CLI commands. Here we prefer declarative approach. Means all the Kubernetes commands will be, Kubernetes configurations will be defined in a manifest file rather than from the CLI. From the single line command, you define it in a manifest file and run the manifest file. These manifest files are generally written in JSON or YAML. We'll be using YAML here in the course, and that's what is widely used. And auto scaling is not possible in Swarm, whereas auto scaling is possible here. Rolling updates with a zero downtime possible here, which is again not possible over the Swarm. Right? These are very simple differences. We have many other differences once we get into the architecture of Kubernetes. It has got advanced and extensive features which you wouldn't see in a Swarm, right? So these are the very basic differences. Mm, Anything else we missed? Anyhow, we'll be looking into them like with the hands-on, but just the basic differences I have highlighted here. Yeah. So let's get into the architecture of Kubernetes. You have a different architecture in Kubernetes. Let us look into it. Again, you will have a cluster here, Kubernetes cluster. This will be having something called Kubernetes nodes. One node will be acting as a Kubernetes master. The others would be called as worker nodes. So let's get started with the cluster and the components and see how it works and how it offers the flexibility of running containers from different runtimes and auto scaling, rolling update, all of these are how it works. Let's get started. This is just the few basics. Can you all see this architectural diagram? So, if you see here, you are seeing here actually 3 clusters. This is your Kubernetes master. You are seeing 3 nodes, 3 node cluster. This is worker node 1, worker node 2. You can have any number of nodes in your cluster. Here I am showing you a 3 node cluster. Control plane is called the master node. Master node is called the control plane of the cluster because it's a decision maker. That's a leader decision maker which is responsible for all the high availability, load balancing and all. So that's called as control plane of the cluster. And others are all called as worker nodes. And again, if you see, there were so many other components in the worker nodes and the master node, right? So let us look into the components of the worker node first. Okay, first I'll start with this component, Docker. Right, in every node, there should be Docker component, means Docker installed and running. Means basically you are running containers, means Docker runtime should be installed, right? So that is what it is. And another thing is, like we were talking about Kubernetes can run containers from any runtime, right? Any runtime means it could be Docker containers, like I said, different container runtimes like Rocket, LXC, OCI, and so on. So Kubernetes can orchestrate containers from any runtime. So whichever runtime we are using, that particular runtime should be installed. Right? That's what is a Docker first component. Your Docker container, Docker daemon, Docker engine should be installed. So that's the first thing. Second thing is the kubelet. Kubelet is called the Kubernetes agent running on every worker node, right? That's called the Kubernetes agent. Means from the master, master will give instructions of how many containers to run, how to run, on where to run and all. So all those instructions will be communicated through to this kubelet. Kubelet is the one which starts the containers on the worker node. Like I said, it's just like a Kubernetes agent running on the worker node. It is the component which communicates with the master, right? So that is the kubelet component. And the other one is the kube proxy. So kube proxy, as the name says, it's like a network component of the cluster. Means the containers on different worker nodes should communicate. They should communicate internally as well, right? All of this communication will be taken care by kube proxy. That's called as network brains of the cluster. So those are the first 3 components which should be available on every worker node. Then comes the fourth component, which is called pod. This is the most important component which we will be communicating or using regularly. That's the pod. So what is a pod? You can imagine pod is like a wrapper around your container. This is your pod container. So pod is like a wrapper around your container. You can imagine chocolate with a wrapper, right? Or else nut with a shell. So the nut is a container and the shell is the pod. It's like a living environment for your container. Your container lives inside the pod. It's like a home for your container. In a Kubernetes cluster, you will never see container deployed like this directly without pod layer or a pod shell, whatever you call it. You will never see something like this. Always you will see containers wrapped around a layer called pod. Means pod is the basic or the fundamental unit of deployment in Kubernetes cluster. Means you deploy the pods, you scale the pods, you delete the pods, you modify the pods, whatever. You basically deal with the pods because that's a basic or fundamental unit. Till now, I'm talking about you run Docker engine so that because you need to run containers, right? Because we don't know pod at that moment, I'm talking about it. But always we say deploy the pods, scale the pods, delete the pods, right? Or pod is crashed. This is the terminology we use. And that's the basic or the fundamental unit of deployment. Like I said, this pod is like a home for the container. Every pod will be assigned with some IP address and it will have some network interface. Container will share the same pod IP and the same pod network interface. Means container can be accessed with this pod IP, colon some port number, right? And there could be a general practice, general use case is one container per pod. That's a general practice and that's a best practice. There are use cases where there might be multiple pods in the same container. Okay, there might be multiple containers in the same pod, but that's a very rare use case. But that is also possible, right? And suppose, let's say, there is a pod with one container in it. Mm. This is the container. And let's say that's an Nginx container and this is a pod. If you scale it, so another pod will be created with the same Nginx here. Means that's a replicated. Right? This is how you scale them. It's not that containers would be scaled within the same pod. This is how you scale it. Right? Let's suppose, let's take another use case. You have a pod with the two containers like this. This is from Nginx. Let's suppose, for example, this is for Tomcat. When you scale it, okay, you will have the pods replicated this way, which will have the same containers as such. Is this clear? Right? So this is how you scale the pods. And whenever you deploy a pod, it will be running on a particular worker node. A pod will not be shared across multiple worker nodes. Means whenever you started, a pod will be started like this. Okay, let's say it has two containers. It should be started this way. But it wouldn't be something like this is not possible. Am I making sense with this diagram? So when you start a pod, it's like a single entity. It will be started on a particular node. If there are no enough resources, it might be in hanged state. But it's not like half of the containers in that pod will be in one node and half will be in another node. No, this is not possible. Okay, anyway, so that is a pod. Pod is like a layer above your container. Okay, we understood it's like a home for your container. It shares the same network interface to the container. But can you tell or can you imagine what is the importance of this pod layer? Why you should have this pod layer? How is it important? Anyone? Any guess? What is the importance of this pod layer? Pod is like a layer of abstraction. What is meant by layer of abstraction? Like we learned, Kubernetes can manage containers from any runtime, right? So it can manage containers from any runtime. So this layer of abstraction helps the pod so that it could be Docker containers or LXC or OC, whatever it is, you deal with the pod in the same way. Irrespective of the container runtime, the pod works in the same way. That's why it's called layer of abstraction. You scale the pods, you delete the pods, everything remains same. Right? That's why it's called a layer of abstraction. That's the importance of that pod layer. So those are the different components of your worker node. Were all the components of the worker node clear? Is this much clear for everyone? Understood? So if these components are clear, let's go to the worker node. Okay, if you come to the worker node, you can see here um, scaling. Where is scaling? Scaling of the pod, Surendra. Is it about scaling of the pod? When you scale the pod, whatever let's say you have one pod with a one container in it. When you scale it, you will have the replicas of it created. Similarly, if you have a pod with the two containers, you will, when you scale it, there will be n number of pods created with the two containers in each. That's how scaling happens, right? Coming to the control plane, this is called the master of the cluster, master node of the cluster. Because it's a decision maker and that's the one which is responsibility for all the orchestrator's features, we call it as a control plane of the cluster, right? And again, there are different components of it, like API server, scheduler, controller manager, HCD. So these are the different components you have in a control plane or in the master node. So if you look into this, first one is API server. And before that, one more thing, you might have noticed something like unlike in Swarm, master will not take any load. If you remember Swarm, like initially all the containers, I mean, we can start containers on every node in the cluster, including manager node, right? But here, you will not start containers, means containers will not be started on this master node by default. Master node will be in the tainted state, means it will not run any load, any containers. Of course, the default container, default pods, system pods might be there, but the user deployed pods, user defined pods, as we start our deploying our pods, we don't see any of them going on to master, right? Because your master will be tainted, it will be off from taking any load. Right. So it has got again different components like API server, scheduler, controller manager, etc. Let's look into each component. So master node is called the control plane of the cluster, and this API server is called the core component, or else this is considered as a brain of the cluster. Right? Any input is given to the API server. And how do you give the inputs? Through the like a Kubernetes commands, right? Like I told you, you have a declarative approach is preferred, but you can also use imperative approach, but declarative is preferred. But whatever it is, all the commands can be through the CLI, right? Majority of the times, like 99% Kubernetes will be using CLI. Also, Kubernetes has got a UI, user interface, which is very less used. But yes, through the user interface also, you can give the inputs. Whether you give the inputs through the user interface or through the CLI, where CLI is the one which is widely used and should be preferable, all the inputs go to the API server. Means any commands you run, let's say you want to start 5 pods. All of that inputs goes to the API server. API server is called the core component of the cluster. It's called the brain of the cluster. So all the inputs are given to the fed to the API server. API server is the one which validates the inputs given. And once these commands are, I mean, once the input is validated, it will send the instruction to the scheduler. Scheduler, as the name says, this is the component which schedule the pods. Means this scheduler is the one which knows when to start a pod, when to start a pod, where to start a pod, right? Which pod should be started. All of this information will be handled by scheduler. Scheduler, as the name says, it knows, okay, today at 7 a.m., a pod should be scheduled on worker 1 or a pod 2 should be scheduled on worker 2. All of that kind of scheduling will be done by the scheduler. So API server will validate the input. Once the input is validated, it will interact with the scheduler. Scheduler is the component which decides which pod should be started on which node, right? So that's how scheduling happens. And when before scheduling it, scheduler will also interact with another component called controller manager. Controller manager, as the name says, it's a manager for different controllers like node controller, pod controller, replica controller, endpoint controller. There were so many controllers. In simple, this controller manager will be checking your actual state across the expected state. Expected state is what you provide in your input, right? You are providing input to API server, asking or configuring, like letting it know that you need 4 pods. But let's say actually there are only 3 pods running on the cluster. All right, that's what is actually present in the cluster. So it will compare the actual state with the expected state defined in the manifest or defined in your commands. And once it compares, it will identify, okay, let's say expected is 4, but there were only 3. So it has to start a new pod. So it will do this comparison and give this information to the scheduler. Scheduler will schedule that 1 pod which is to be started on the worker nodes accordingly. So this is what controllers do. Also, to do this check, controllers will be running some non-terminating or unending watch loops. It's like a watchdog of the cluster. It will be running non-terminated continuous watch loops to make this comparison and find out what should be done, what should be deployed on the worker nodes. Right? Accordingly, the necessary steps would be taken care. Is this clear, everyone? So non-terminating watch loops will be run so that it will identify these things and it will provide the information to the scheduler. Scheduler will start the pods accordingly in the cluster. So basically, if you see API server is interacting with the scheduler, it gets the information from controller manager, all of that will be validated, and finally pod will be deployed on the cluster. How will be pod deployed, or how will it give instructions? This API server will give instructions to the kubelet. Kubelet is the one which starts a pod in the cluster. Is this much clear? The first 3 components clear for everyone? Right. So this is how these 3 components work. And then again, there is one more component called HCD. HCD is called memory of the cluster. Right? It's called NoSQL database. Data will be stored in the HCD in the form of key valued pairs. Right? What information will be stored? Information of your deployments of your cluster, information of your cluster, like how many components, how many pods are deployed, or like, see here, like we discussed, like controller manager will compare expected state with actual state. And how is controller manager getting this actual state? Isn't it? Also, scheduler is deciding on which node it should deploy. How does it know what are the number of pods available on this worker one, and what are the resources available on worker one? All of that information, how do scheduler know to make a decision? Isn't it? All of that information they will get all this information from the component called HCD. HCD is like a store key value pairs. Data will be stored in the form of key valued pairs. All the components will fetch the information of the cluster from the HCD and process them and performs their task. That's why it's like a NoSQL database. All the data will be stored. HCD is very, very important because all the cluster configurations information is stored in this HCD. Is this clear? Controller manager is like a watchdog of the cluster, Surendra. It will be comparing actual state, means what is present in the cluster actually, let's say 3 pods. And what is expected, means what are the input user has given. As a Kubernetes user, I might be configuring it to start 4 containers, 4 pods. So it will get the expected state, actual state, which is stored in the HCD, and it will compare them. And if there is some difference, It will send the information to scheduler. Scheduler will again get the information from HCD regarding the available resources, the health of the nodes, the number of pods available on each node, all of that, and it will decide on which node a pod should be started. And it will accordingly send the information to the kubelet and the pods will be started. Got it now? Still any confusions from anyone? Are all the components clear? Is the architecture clear for everyone? There is a question from JP. If I want to start, if I want to scale out 4 pods, but scheduler has only chance of having scale out only 3 pods, will pod shift to another node? First of all, scheduler is the one which decides a pod should be started on which node. Correct? Scheduler is the one which decides on which node a pod should be started. How is scheduler deciding it? By getting the resources of those worker nodes from the HCD. Hope that answers your question. As it gets the resources, information, health of the worker nodes from the HCD, it will decide on which node it should be started. And if there are no enough resources at all in any worker node, the pod will remain in a hanging state. If you have implemented auto scaling, a new worker node will be started and scheduler will schedule it on the new worker node. And Ram Prasad says how network connectivity takes place in Kubernetes. Network connectivity in Kubernetes is handled by network plugins. There are CNI plugins like Flannel, Calico, different network plugins are there which has to be installed in the Kubernetes cluster. And using that network plugin, kubeproxy component will take care of networking of the cluster. You don't need to set up the networking separately. You have to configure some network plugins. Any more questions?
Uh, yes, thank you, ma'am. So I see. So this kube proxy, is this usually the reverse proxy in this?
Kubeproxy is a component which will take care of networking, like communication between the pods in the same node, or communication between the pods in a different cluster, or communication between the master and worker nodes. This connectivity, this communication will be handled by kubeproxy.
Okay, because I've always heard about the reverse proxy being in, available for the communication between that any certain, I don't know what to call it or say it, but
It,
reverse proxy is always in the middle, which communicates with the internal other maybe pods or the nodes or whatever it is. So I wanted to
yeah,
confirm.
yes. How many containers can we store in a single pod? Generally, always best practice is 1 container per pod. You can store up to 6 also. There is no number, specific number, I believe. It's like a 6, but I don't think we'll be running 6 also. Maximum 2 or 3, not more than that will be seen. I have seen till 2 or 3, not more than that. Any more questions?
One more question. So actually, I missed the initial stage for 5 minutes. So cluster means this complete setup. This what is meant by cluster? Can you say
Cluster means a bunch of nodes. It
bunch of nodes? Okay.
master or worker node combination. It's a bunch of nodes as a cluster.
Um,
Okay.
Ma'am, here, so how would we correlate in a with the real time here? As in, I mean, so now we understand this architecture, but so worker nodes, would those be VMs, individual VMs, or this whole cluster would be, or there will be multiple clusters on one VM, or what kind of a scenario is it? as per the real world.
This is the architecture, right? Architecture remains same in the lab or in the real time. And I understood your question, like what will be exactly worker node work, right?
Yes,
These could be these are nothing but your servers. They could be a server on on-prem, means this is one server. Server on on-prem means a machine basically. There's another server. It could be an on-prem or it could be on cloud or it could be a virtual machine. They could be anything. This is one more node. Node is a machine which can start, which can shut down. It's a server. It's a machine. All
right.
of that combination is a cluster, out of which one of them will make it as a master node. Others will be worker nodes, which run the actual load.
Hi Priti, I have one doubt.
And 1 second, we are going to create this cluster on on-prem as well as on cloud. So all of these queries will be resolved. Yes.
Okay.
Yes, please go on some of your things.
Yeah, hi Prati. Actually, yeah, in control manager, expected state and actual state, currently we require the 5 pods, and currently actually available is only 3 pods, and remaining 2 pods are still waiting up to other pods are completed, or in which place these 2 pods will be waiting.
See, you gave the input saying that you need 4 pods, right? But let's
Yeah.
or 5 pods, whatever it is. So 2 pods should be started. So this is identified by controller manager. Controller manager will give the information to scheduler. Scheduler will get like the information. It should decide on which pod these two, on which worker node these additional 2 pods should be started. It will make a decision and it will give the inputs to kubelet. Actually, it will give inputs to API server. API server will send the input to kubelet. Kubelet will start them on whichever worker node the decision is made. That decision is made by getting the available resources, health of the worker nodes, all of that information from HCD, and scheduler will make a decision. So which are waiting, like where do they want to wait? See, this all happens in a fraction of seconds. Whenever you run that, like you run a command to get the pods, it will check, controller manager will be checking all of this. Means API server first will validate, will send the information to other components. Other components will check, okay, it has to start 2 pods and the 2 pods will be started. What is meant by where 2 pods are waiting? Now you put your question again, please.
Okay,
There
Priti.
are no enough resources for these 2 additional pods. They'll be in the hanging state.
Thanks, Priti.
Right. All Kubernetes setup done by administrator team or need to do by ourselves. Okay. Kubernetes cluster setup in some, okay. Admin team, in the sense, there'll be different teams like Kubernetes admin, Kubernetes development team. Development team means, again, not developers who will work on only deployments, who will work on only deploying the pods, writing the configurations. Right? Both these are DevOps teams. You might be in a Kubernetes admin team or you might be into Kubernetes dev team. You have to understand the job description again to understand the role exactly. So there'll be 2 separate teams, but in some companies, there'll be only one team called Kubernetes team who will do everything. Or in some companies, there'll be DevOps team who will do everything, including the pipeline setup, including the cluster setup and all, particularly in startup, which I did as well. It's again, like that's why those startups will give you a platform of a great learning. Only one single team who will work on cluster administration, cluster setup, deployments on the cluster, pipeline setup, everything. You will not have any breathing space, but you will learn many things in those projects. I have also worked on project where there's separate admin team who will take care of the cluster. We will not see the cluster, will not have any exposure to the cluster at all. We'll just do the deployments. So whatever, like that's different ways you have. Any more questions from anyone? So that is about the architecture, right? You will see all of this in with the hands-on in some time. Now, as you understood the architecture, let me take you to the setup discussion. Let's talk about the cluster setup now. So coming to the cluster setup, your cluster, like I told you, Kubernetes cluster setup can be done on different platforms. Like it can be on-premise cluster setup, or it can be on cloud. Again, on cloud, you have Google Cloud, okay, GCP, Google Cloud Platform, or it can be AWS, or it can be Azure, or it can be anything, right? So first, let's talk about on-prem kind of setup. On-prem kind of setup is the complex setup out of any type of setup, right? Here, you will be having some servers. Okay, you will take those servers, configure the components from the scratch. Like you have to install the components like Kubernetes. Okay, first let's forget about Kubernetes. Let's say you have to install the API server, scheduler, all these components from the scratch. You have to download them as a tar files and configure them and bring them to working. Or else there is another component called utility, actually called Kubernetes. That's a utility with which you can, okay, let's say you have some virtual machines or servers. You can use this utility. This Kubernetes will start up all those components and will create a cluster for us. So that's another way that's how we can create a clusters on-prem. So here we'll create this cluster setup first, because if you understand this kind of cluster, you can work on any other clusters very easily. So we'll get started with this. But we don't have our own on-prem servers, right? How do we do that? What we'll do is we will take some EC2 instances on AWS, and then on top of it, we'll use Kubernetes and we'll create a cluster. That's how we'll create this cluster, right? So once you know the actual cluster components, how they work or not, we will learn almost everything here, right? And once we learn all the concepts, then we'll go to cloud. So you will understand the cluster setup very easily here. GCP provides a managed service called GKE, Google Kubernetes Engine, which is absolutely free, which is very easiest way of cluster creation. With a single click, you can create a production grade cluster all for free. It is providing this because GK, it's like a pre-package which comes from Google Cloud, because Google is initially a product of Google, right? That's why we have this facility, this feasibility. You can create a production grade cluster with a single click, completely free here. Completely free in the sense, the cluster service, GKE is a service, like you have EC2 service. This is a service. This is free. The underlying machines you use and all will be charged, but yes, this is much better, very economical to use. Okay, and then AWS also offers a service called EKS, Elastic Kubernetes Service. This is a paid service. Okay, the clusters setup is moderate. You can set up it in different ways. You can create the cluster from the console like we created EC2 instances, or you can create it with AWS CLI commands, or you can create it with a component called EKSCTL, or you can also create with the Terraform by using again the previous components like EKSCTL and all, whatever. So different ways of cluster creation. And once, see, the setups are different. But once cluster is created, the way you deal with the cluster, the commands, concepts, all are same. So we will also work with this cluster setup. It's a paid service. So it's up means this EKS service itself is a paid service. It charges up to, I think, $0.01 per hour with for this service alone. Okay, apart from this service, the EC2 instances you are using, the load balancers you use, all of that will be charged separately. So you have to take care of your billing. So it's up to you whether you do the hands-on or you will just listen. It's up to you. I'm covering this because in the market, almost 50% of Kubernetes clusters are EKS clusters. So having good exposure to this will help you. Again, Azure offers a service called AKS, Azure Kubernetes Service. So again, similar way, you have to create a cluster and all. So these are all managed service on cloud. If you know one managed service, that is enough. And we are covering EKS here in this course, an on-prem kind of setup. Both are having very good demand. People with on-prem cluster setup are very less. This is having very huge demand. Of course, this is a complex depending on that particular on-prem server setup, because depends on the network configurations in that particular organization, how the servers are configured, network configurations of it and all. These are the two setups which has a lot of demand. If you know these two, that is enough. Okay. So this is what first we'll get started with on-prem kind of setup. We'll use some EC2 instances. On top of it, we'll use Kubernetes and spin up our cluster, and we'll learn all these components. Sorry, and we'll learn all the concepts of Kubernetes. Then we'll go to EKS to cover advanced concepts like auto scaling, load balancer service. This is again different topic. So, and again, we'll also learn Argo CD on the EKS. So this is the plan. Now we can get started with on-prem setup, create a cluster and get started. And these are all different ways of clusters, right? For your learning, you can also go with another kind of setup called Minikube. Minikube is a single node cluster. Okay, it is for your learning. For your learning, you can go with it. Means this Minikube single node cluster can be created on your laptop directly. Whether it is Windows or a Mac or Linux, you can directly create a cluster and you'll get started with it also. What the plan is, yes, we'll get started with on-prem, we'll learn all the components. Sometimes what happens is, these resources will not be enough as we are using T2 micro. Some of the components like Helm cannot be dealt on with T2 micro. You have to go with the T3 medium instances, which are again paid. Like they are not free, they are eligible. You have to pay for them. So instead of that, you can go for such concepts on Helm on your laptop. Or if you want to go for a paid, you can go for T3 medium also. It's up to you. Am I clear? Appreciate your quick responses. You can go for Minikube, and why you should go for Minikube and all I have explained. Is this much clear for everyone? And there's a question from Ram. In on-prem, we can use tools like Minikube, not on on-prem. Anywhere you can use Minikube. Micro K8s, yes, you can. Is the difference from Kubernetes? Why majority we go with Kubernetes? Kubernetes is the stable and officially referred by Kubernetes. Some Minikube is like a single node cluster. That is just for learning purpose, dev environments we use, not for prod. Micro K8s, these are all different Kubernetes solutions offered by different vendors and all. Each has got its own pros and cons, but these are the ones which are used across the orgs. So let's get to some EC2 instances, create a cluster.
Ma'am, query.
Yes, please.
Here out of these three, which is the most reasonable for the practice purpose? Let's suppose we want to deploy entire CI/CD, the small with some small program, not big or something, just like address book we have. So which will be like a good one where we can do it.
Minikube.
Uh, no, I mean GCP or AWS or Azure. Cost wise, I mean.
Cost-wise, I told you very clearly, AWS is a paid one, GCP is a free one. Whichever you want, you can use. More widely used ones is EKS. So it's you have to decide which one you will use. I told all the pros and cons.
Okay. And suppose we are creating virtual machines on our own machine. So until now, whatever tools we have learned, and the next ones, few of them will be coming up. So like, how many virtual machines would be required approximately?
Same like how many EC2 instances you are using, those you have to use.
Oh, okay. I mean, approximately like 5 or 6 or like. Means each tool.
There will be nothing like how many machines you will use. It depends on the design of your pipeline. In our Jenkins pipeline, till now we have used some slaves, right? Without slaves, if you use everything on Jenkins master, only one is enough.
Enough.
So there is nothing like how many you need. It depends on how you design and how you want to bring up your pipeline.
Right. No,
So
I mean
also
for the
VM
practice
setup
purpose.
is not for practice purpose only. That's how you want to do practice. Whether you want
Okay.
to create your slaves separately. In real
Mhm.
time also you can't give the number anywhere. There is nothing like how many VMs you use.
Mhm.
It's up to you how you want to practice. And I wouldn't recommend using VMs on your laptops. That will not help you in any way because VMs are nowhere used. It's all easy to instances. I mean, cloud instances we use, right? So better you practice with that in the free tier limits.
Mhm. Okay. Okay. Sure. Sure. Thank you.
Priti, one small question. Sorry. So what about this Rosa? Because in the real time we are using a Red Hat OpenShift service.
I'm not sure about Rose, JP.
Okay. Because
OpenShift,
yeah, Red Hat OpenShift
these are the
service.
different solutions for Kubernetes. Different solutions offerings on Kubernetes, like OpenShift clusters. These are all different solutions. Like EKS you have, which provides a Kubernetes solution. Those are all different solutions from different vendors.
Okay. Because we are using Rosa service in AWS, we have configured everything on Rosa. So we are just trying to migrate from Rosa to EKS,
Like
completely
I
shift.
told you, there are different offerings provided by different vendors for Kubernetes, right? OpenShift solutions and so on. Setups
Okay.
differ, the way you set up the platforms differ. Concepts, commands of Kubernetes remain same.
Okay. Okay, Priti. Thank you.
All right, then let's get started with the setup. So now let us create a cluster. I'm creating a 2-node cluster, right? You may create any number of nodes. I'm going to create a 2-node cluster and T2 Amazon Linux to T2 Micro. One more thing is T2 Micro instances provide you one vCPU and 1 gigs of memory, right? The prerequisite to create a cluster is it should have at least 2 vCPUs and 2 gigs of memory. That's a prerequisite to create a cluster, to create a Kubernetes cluster. Okay, here you can see 2 vCPUs. Where do you get? You get it on T2 medium, 2 vCPU and 2 gigs minimum. So these are not free tier eligible. You will be charged 0.0496 USD per hour. So I'm just going with T2 micro and it will override the error coming with regarding the CPU and memory. But like I told you, this will you may not be able to explore all the features with this, like particularly Helm and huge deployments. If you have, it wouldn't support, right? But we can learn all the concepts here. And what I will do in this course is I will cover almost all the concepts here, whichever I can. Wherever I don't have enough resources, even though we clean up everything, it cannot accommodate, particularly Helm components. Such things I'll go to Minikube cluster. Minikube cluster setup also I'll show you once I start it. That is the best way to learn, spin up your cluster quickly and a free cluster. So for now, yes, Amazon Linux 2, T2 micro instances. Key pair is AWS. I'm just using the same key pair. It's up to you how you would use your key pair. Launch the instances. I would like to make one of them as a manager, the other one as a worker nodes. Okay, just naming it as master. We have to make it as a master. They are just VMs now. Actually, you might have some on-prem VMs, right? Physical servers where you create a cluster. But for now, this is what we have. We will not use any managed service like EKS as of now. What is meant by managed service? Like you have EC2 and all, you can search for EKS, Elastic Kubernetes Service. Okay, you can create a cluster by clicking on this, like from the console, I told you, right? Click on create cluster, it will ask for cluster name, the node roles, different things, and you can create a cluster this way here and use this cluster. When you create a cluster, it will show the list of nodes, which will be again EC2 nodes. But we are not doing it. We are taking EC2 instances, like just a standalone VMs and creating cluster with them with the kubeadm utility. So let's connect to those instances. Okay, this is going to be my master node. Let us also connect to the other node. This is going to be the worker node. Okay, terminal color is different. This is going to be the worker node. So two machines are ready. So yeah, firstly, there were few steps we need to execute, like just changing the host name. That's not mandatory, but good to have. Just a second. I'm using the installation document from the website. Okay. So first thing first, like this is the host name of it, right? We can change the host name for a better one. Like, so let me set the host name as master node. This is good to do, not a mandatory one. I'm naming it as a master node. And also, let's put this on slave. Okay. Right. So I just changed it and now they should resolve each other, right? They should understand each other, resolve their host names. So for them to resolve the host names, put those entries in the etc host file. Like here, we will add the IP address of the master node. Let us get the IP address of master, private IP for internal communication. And the host name is master node. And then private IP of this worker node. Okay.
The second one you have to do in the worker node, right, Priti? You're adding.
Since you should have these entries. Each has to resolve the other one, right? Go to the worker node. So this should be added in here as well, the same entries. Okay. Done. So they should be resolving each other with their host names. And also one more thing, these are Amazon Linux 2 instances, which are CentOS or Red Hat based ones, right? So here you, there is something called security in Linux, which you need to disable it as well. These are OS specific commands, set enforce to 0. So that they can communicate, nodes can communicate. So we did few changes for these changes to get into effect. reboot the instances. It may take a while and get them started. So now once they get started, we can install the components. This is available and you can see the host name got changed. Do you see that? You see the host name as master node now.
Host
Let
name
here
city. Host name CTL.
yeah, we have got this changed. Right. So now let us install the components. What are all the components we need to install? We need to install something like Kubernetes, first thing, first component. First component we need is Kubernetes, right? Utility to create clusters and manage clusters. This should be installed. Kubelet should be running on every node. So Kubelet should be installed. That's a Kubernetes agent running on every node, right? That's how API server will interact with. Kubelet should be installed. Docker should be installed, which is a Docker container runtime. And another component called kubectl. This is called Kubernetes command line utility. What is this? This is the what will help in interacting with the cluster. To deploy the pods, to deploy anything on the cluster, you need kubectl. Whether it is on-prem cluster or EKS cluster or GCP cluster or whatever, Minikube, whatever it is, this is the one with which you will interact. This need not be installed on the cluster. Actually, this can be from a machine from where you will interact, you will connect to the cluster. These are the 4 components you have to install. So you cannot install them with yum. Yum doesn't provide with these utilities. So we are going to create a Kubernetes repository file, right? Like we have a Jenkins repository file created, if you remember, right? Similarly, we are going to create Kubernetes repository file from where these components can be installed. See, I have created a file called Kubernetes repo. Do the same on the worker node as well. And now install these components and install the specific version of the components. Right? I'm installing 21 version. Do the same here as well. We need few components here, right? So done on a master node. Now start kubelet. Start kubelet and Docker. These 2 should be running and that's a mandatory for your cluster to work. Also enabling them so that during reboot or startup, your server will be started with the kube system CTL enable kubelet typo. Sorry. Okay. So do the same on the worker node as well. First start those components. And then enable those components. Now all the components are installed. All the prerequisite components are installed. Now we can get started with the cluster creation. So cluster can be created with the utility kubeadm, right? Kubeadm init, right? Like we initialize swarm cluster, init command to create a cluster. This command should be run on the node, whichever you want to act as a manager. I want to make this node as a manager, so I'm running it. You need to have the IP address of your master or a manager. Actually, it's called master. So get the IP of this. This is the command, kubeadm init, API server advertise address, the IP address of master. Ignore the errors regarding CPU and memory, right? Because we are using T2 micro instances, which offer 1 vCPU, 1 gigs of memory, which will not allow cluster creation because Kubernetes cluster prerequisite is 2 vCPU and 2 gigs of memory. So to override those errors, we are doing it and creating a cluster. This should start a cluster. It will take a while to create a cluster.
Pretty like after setting up everything, we will configure the kube proxy for network related, or then here only we need to.
This cluster creation means those components will be created. If you see here, it's creating all those components. Kubelet, controller manager, API server, scheduler. You can see all of those components getting ready with the kubeadm, right? So cluster is created and it is giving you a token like in the swarm. You can join any number of worker nodes by running this command. They'll be connecting on port 6443. So we need certain ports to be open here. So I'm just going to security. Both the instances are using the same security and I'm adding all traffic here. Okay, so that they can communicate. Now take this token and run on the worker node. Okay, but before that, just a second. And run on this worker node. Okay, meanwhile, it joins the cluster. Just come back here. Your Kubernetes control plane is has initialized successfully. So your master node is ready. And it is saying, like generally, whenever you create a cluster, in the same home directory, I'm creating cluster with root user, right? In the same home directory, there'll be a file called admin.conf file created. That is used for authentication and authorization to the cluster. But always will not have root user privileges. We should be connecting to the cluster as a regular user, EC2 user, or any other user. So I'm just switching to root user, EC2 user, and with whatever user I want to connect to the cluster with EC2 user, EC2 user should have this admin.conf in the kube folder. So that's what I'm doing. I'm going to create a folder called .kube in the EC2 user location. Then copy that admin.conf as a kube config file. Means in the .kube folder, config file should be created, which will take care of authentication and authorization and provide the relevant permissions. Once you do this, as a EC2 user, you can connect to the cluster. First command, get nodes. kubectl, I told you, right? Utility to interact with the cluster. See, this is the master node is added. Worker node is also added. Means here when you run the token, yes, this node has joined the cluster. We will not do anything on the master, just accept this token. Your cluster is ready, right? So only thing is here as EC2 user, you might be having .kube folder created config file, right? This is for authentication and authorization. That's called as kube config file. And your nodes, your cluster with the 2 nodes is ready. kubectl get nodes is the first basic command to check the nodes in your cluster. And if you see, they are not yet ready because certain components are not ready. What are those components and how do you see them? You can see them with command kubectl get pods -a. A means all namespaces. What is namespace and all we will learn later. Just use all -a and you can see all your cluster components like API server, your controller manager, kube proxy, all of them are here. And if you see some of them are in pending state, right? You have to install network plugin like I told you, some network plugins like Flannel or Calico so that your nodes will be in the ready state. So how do you install anything in a cluster? Like let's suppose I want to have some Nginx service. How do you install it in your cluster? Through a pod, anything will be deployed as a pod. Same thing I'm doing. I'm going to install network plugin. So there were pods for it coming from a manifest file. This manifest files you will understand in a while as we progress. Just understand we are installing some plugins here, network plugins. Now that you have installed this Calico network plugin, your node should be ready and you can also see all the pods which comes into, see they were still in pending. As long as they are pending, your nodes will also be in the pending state. Right? Your pods might be ready by now. Node group is still coming up. Actually, they should all be running state. See, slowly they are all turning into running state. Do you see? First of all, pod initializing is the first state. Means pod is starting. Second state is container creating inside the pod. Once the container is running, it will turn into running state. Now all of them are running. Your nodes will connect now. Like when you deploy something, you can see their communication. Right? So this is your complete cluster setup with the kube adder. These are the 2 nodes which are ready, which are connected. These are the system pods. So cluster is ready. Any questions? Kube proxy should be installed. Okay, for kube proxy to work, network plugins should be installed. Network plugin is separating which should be installed on top of kube proxy. Both are
Priti, for this Kubernetes cluster creation, all these commands which we are running currently, these are available in the document.
They
We
are
can
all
run.
available. You can check on the drive. Okay, all of these will be available. In assignments also, they should be available. If not, you can refer the drive.
Means do we need to run the same or any modifications is required?
Same, but you should keep your own IP address, right?
Yeah, IP address okay. And
Okay.
rest all, yeah.
Yeah, same commands. So now that cluster is ready, okay, you can deploy your own applications like address book or whatever. Okay, let us start deploying some applications. Okay. So let's deploy some Nginx. I just want to start with some Nginx, but always like I can do this way. This is the imperative command kubectl run. I want to give pod name as sample coming from image Nginx. No tag means it is latest. See how is container created from an image? Same concept. That's why Docker concepts are very important. Nginx is a Docker image. I'm not putting tag means it will use latest tag. I'm not using registry means it will pull from Docker Hub. It will pull from Docker Hub, create a pod. Right now, when I run this, what happens? A pod will be created by name sample, within which there will be one container which is coming from Nginx. That's a simple imperative command to create a pod. kubectl get pods. Don't use -a so that you will see only your pod. See, firstly, it's into container creating state. Then it goes into running state. If you want to see more information, you can do describe pod. Right? You can describe it so that it will show you on which node it is running. We have only one worker node where it will run. So worker node, name of it, and then the IP address of the pod. Every pod will be assigned with some IP address. All the details. And if you just come here, events will show you the architecture we discussed. Do you remember we discussed the architecture? Like first what it will do, your pod will be scheduled by the scheduler. Scheduler has successfully scheduled this sample pod to worker node 1. Then kubelet is the one which will take those instructions and which will start the container actually, right? Default scheduler means scheduler component will schedule it. Once it schedules it and passes the information to the kubelet, kubelet is the one which downloads the image and starts a container from that image. Do you see that? Right? You can see very clearly here. Firstly, it is scheduled. Then it is pulling. Kubelet is pulling the image. Image is pulled successfully in 8 seconds. Sometimes we were talking about image size, right? Image size matters here, right? If it is huge image, if it may be for 30 minutes, it may be still pulling from 1 minute. It could be because of image size or network issues. That's why your images should be of like a slim size images with the best practices like multi-stage builds, right? All of that concepts are here. Then it has created the container successfully and started successfully. All the steps are here. Get pods. PO is a shortcut. If you want to see wider information like on which node, worker node 1, the IP address of the pod, that's how you can see. Right? This is called the imperative approach. With a single line command, I deployed the pod. But this is not a good practice. In Kubernetes, we prefer declarative approach. What is meant by declarative approach? Means you should define your requirements through a manifest file. Okay, fine. I'll deploy it through declarative approach, which is the real case. But before that, I would like to clean up. How do you remove it? kubectl delete, type of the object, and then name of the object. Delete pod sample pod so that it will clean up. It will delete the pod. There's nothing. Now let us deploy it through the declarative approach. Declarative approach means write a manifest file. Okay, fine. Any name you can give to manifest. I'm giving name as pod.yml. And this is where there's a misconception. Kubernetes needs coding. Lot of coding is there in Kubernetes. These are the manifest files which follows the pattern. You don't need to know coding for this is what I'm talking from the beginning, but there is a lot of buzz, lot of confusions, misconceptions that writing Kubernetes files needs coding and all. You tell me if it is coding or not. I'll show you how I write it. This is the Kubernetes official documentation, kubernetes.io. This is the official page which you can refer in your real projects as well as an interview as well as in certificate exams also. Because Kubernetes is an open book exam, right? In certifications also you can refer this. You shouldn't refer other blogs and all, but official documentation, yes. In the companies also you can, in interview also with the permission you can use it if you want, right? No one can stop or object that. So, okay, come here and search for pod. Okay, here is the pod object. Right, so just you can come here, all the pod description, concepts, everything here. And if you just here, this is the manifest file. You have to understand the manifest file. You can use the same. I think I'll elaborate the content of it tomorrow. I'll just show you execution of it in the interest of time. I'll explain this completely tomorrow. Even if you don't understand also, it's readable. It's a YAML, right? This is the kind we are deploying pod, some name to your pod. Let's say I'll give sample. Okay, image name. This is name is container. You can very clearly see containers. Name means container name. Inside the pod, you have a container, right? You may give some name like C1, image name. Image name nginx with some tag. If you don't want tag, latest tag, that's all. And this is port where it is running. That's all. My pod file is ready. I'll elaborate on this content again in some time. I just want to show you that's it. And now run the manifest file. How do you run it? kubectl. For the first time, you can use create or apply also. But from the second time onwards, you should use apply. As it is first time of creating this pod, -f or not. It works the same way like we did some time back. Is this called coding? Do you call this as coding? Right? So this is your Kubernetes manifest files, which is never called as a coding. Development, how developers write the code, that is different. What happened at the backend is same. See the same thing. It has scheduled, kubelet has started it and all. Only the difference is declarative approach. The previous one is imperative approach. Declarative approach is preferred because you can maintain versions of this manifest files on the GitHub repositories. We can implement GitOps principles with it. All of that we'll see. But this is the preferred approach in reality. Always the declarative approach by writing the manifest file. It is in YAML. Again, it's readable. 80%, 80 to 90% you can easily understand by reading it. Right? We will elaborate on each line in some time, but this is your pod manifest file. This is how you deploy in reality. Of course, we don't deploy pod again directly. We'll deploy it through deployment. It takes many folds, but the process is, yes, you write a manifest file and you deploy it. You maintain the versions of it in GitHub so that everyone know what changes are happening there, and that's how it is.
Priti, we have defined the port, right? Here we are not saying with the iPhone worldwide.
We define
We define the expose port is 80, right?
this is not expose port. This is telling that your container runs on this. Exposing works differently in Kubernetes. We'll come to that part.
Okay.
I did not expose here anything. Ports are not exposed. We did not expose here anything. Output wide is you get all of this information. Is this much clear, everyone? Differences between imperative approach and declarative approach. Declarative approach is the one we use in reality, but in certification exams, imperative can be used. Certification is nothing but like it would be kind of the approach of the exam is different. Like you have to know the shortcuts, you have to know even you need to use manifest files also. It's like you study for board exam and you study for competitive exam. That's how the approach would be different. But Kubernetes is completely like the certifications are practical oriented. So understand the things thoroughly before you sit for the exam. Those are the one of the toughest exams. And in one of the interview question, I was asked to write the deployment manifest file. And I did it without the documentation. Like through experience, you get used to this pattern. But if you want, you can also refer it. Generally, they wouldn't ask you to write those manifest files because everyone will be using from here. But I got the query and I could write this manifest file. Through practice, you get used to this format. We will discuss them. Anyway, first we have to discuss this pod manifest file before we go there. So this is a simple cluster setup and deploying a small pod. Lot many things are to be done. How to scale them, how to expose the application, right? How to see the high availability, all of that we'll see. Any questions in this part from anyone?
So this is on premises using the Cube ADM package, right, Priti?
Right.
Okay.
Ma'am, so this one, when we created this YAML file, where does it get put on the file system?
Just wherever you create it.
And
is
it is fine. I mean, okay, so this is for now in a home, and then there is a user folder, and then it got created there. But what I mean to say is, we can put it anywhere within home directory on the master,
see, this is your master node, right?
right?
You don't need to put your manifest files on the master. You don't need to run these commands from the master at all. Actually, you will not log into your cluster at all. Like you may connect from another server called Gem server or Bastion servers. From there, you connect to the cluster and run the commands. Okay, that is the first thing. So from wherever you are running the commands, their manifest files should be. Means your manifest files will be in GitHub. You clone that repository and you run the manifest files to apply them manually. Is that making sense?
Yes. So,
Like
so
we have our Jenkins file, we cloned it into our local and we just pushed to GitHub and the pipeline triggered, right? So you
right, right.
clone your GitHub with the manifest files, Kubernetes manifest files into your local, connect from your local to the cluster and run the kubectl apply commands. Here we are doing from our laptop like a local. It might be another server called Gem server or Bastion servers from where you will connect to cluster and run those commands.
All right.
Kubectl apply commands. So location is not specific. For now, I'm just logged on to my master and creating the files there. You can connect any location you can do it.
Okay. So, in the scenario you explained, mostly rather a real world scenario is that from a certain local machine, we
Not local machine from Jump servers or Bastion servers.
okay, okay, okay.
Hmm. Like
All
you'll
right.
have another server to where from where you connect to your cluster.
Cluster. Okay. That will always be there, which will be within that network, or rather configured to communicate with that
Yeah.
master.
Yes.
Okay.
Yes.
All right. All right. Thank you.
So Priti, what happens if master got terminated or like master node got crashed? So again, we need to create and we cannot do that again, right?
If master goes down, entire cluster will go down. So there'll be multiple masters for managing high availability. So that's the challenge with on-prem kind of setup. It would be very much like a huge task where you have to maintain high availabilities of your master. When you go to cloud managed services, that would be handled by those managed services. That's another advantage on managing it on cloud.
Okay, so that is a basic advantage. Okay, okay, yeah.
Mhm.
Hi, Priti. Uh,
Yes, hi.
yeah,
Uh,
so
Sorry. Go ahead. You were asking
yeah,
something.
thank you. So, Preeti, I have a couple of questions. So, when we say deploy the application, right? So, we generally zip it and place it in our servers, right? So, but when we take as a Docker or Kubernetes, we will wrap that into an image and then deploy that image, right?
Correct.
Yeah.
Correct.
So, when we say this is a deploy step, right? So, when we deploy this using a container, that is a deploy step. So when we are doing our Jenkins, right, we are running our post deploy steps and all, right? So when we do post deploy step, so should we be inside the container or should we come out of the container, because we are again running from Jenkins workspace and all, right? So we should run our script inside that or outside of that container.
Which container?
So
You
we
will
will wrap.
deploy your application as a container. You will
Correct,
not go inside the container. From
correct.
outside, you will be on the Docker host, means on a machine wherever you want to deploy and start the containers.
Yeah,
You'll be
we will
outside.
start the container, but if we need to see post deployment step like manual steps, how we do, right? Our app is up or not. So that we should do after post deploy, right? To
Not
verify that it is a
inside the container, right? To see it is running or not. Why should you go inside the container to see it's running or not? You have multiple ways to check the probes. There could be monitoring done. You can check it on the browser or monitoring setup whether your application is running or not. You don't have to go inside it.
So we can come out of the container and write our automation steps
First of
just
all,
as a
we
command.
are not inside the container. Why should you come out? You deploy a container, Docker run -itd. You are not inside the container, right?
Correct. We are not inside the container.
We just starting the container and then you are on the host only.
Okay.
Once your container is started, unless if you have to check something, you will not step inside the containers. Right? That's for your test purpose, like installing some packages manually and see how it works. That's all before creating your image. Once you create your image, packing everything and it is stabilized, you don't need to step inside that. Like I said again, if you want to test something manually, you will have to do it. General monitoring purpose, general checks like your application is working or not, you don't have to go inside your container. And also, you will not deal with individual containers, right? We will deploy them for Kubernetes, right? Like this, we will deploy some 100 containers. They'll be to which container you will step in, right? They are ephemeral. They'll start, they'll terminate, new one will come into its place. They are like a bundle of them.
Okay.
They are
So
like
our
number of containers you don't have to step into, or see, remember, you will never deal with individual containers or individual pods.
correct. That's the, I mean, in kind of way that is good, but it may be also risk, right? We will be end up in spinning multiple pods if the health is not good, right?
Sorry, come again.
So suppose we spin an application, there is an error in our image
Mm,
which we build. So
mm,
our pods are not up, but
mm.
it start continuously to build pods without terminating, right?
If your pod is failed with an error, it will not continuously pull. If you may see, your pod might be started or it might be failed. It will not continuously pull until it is up and running.
Yeah, but it will be creating some pseudopods at the back end, right?
No. See, you start a pod, let's say, just now I started engineering, so your pod is started. If something with the image incorrect and all, your pod will fail, that's all. It will not
Okay.
keep on pulling the pods. It's about your image. First of all, image will be developed in dev environment. It will be tested on multiple environments. Finally, it will be deployed in prod. If any errors, corrections, all of that will be handled at that point. What happens if your image is errored and all, we will see. It will not keep on running the pod until it's active. It's a problem with the image.
Okay. Yeah, maybe my thing is something different. I will come once you cover the load
We will
balancing.
deploy our applications, address book, PHP and all. Okay, your questions will be answered there.
Yeah, but post deploy should be run inside our normal space only, right?
Post deployments, what exactly? Post deploy could be many things, right? What exactly you want to post deploy meaning? It is deployed on Kubernetes cluster. Okay. Now, what is post deploy in your case you are referring to?
So if we need to run our tests, right?
Test
So with
like
respect to
application is
blue
running.
green app, yeah. So
Hmm.
mine is a blue green app, and if you need to test blue is app and just to switch the pods and all.
You don't have to go inside the container. You will check that endpoints. Your
Okay.
Prometheus is there to test the endpoints are working or not.
Okay. Yeah, got it.
There'll be a load balancer, global load balancer, and you will check the endpoint if the application is running or not, or if any service status you want to check, you have monitoring tools which will do that. For that, you don't have to log in. Even in our case, like we deployed address book, we are checking the endpoint. Did we go into the pod to check whether it is running or not? Just for our learning purpose, what is happening inside, I have taken you and shown you, okay, this is how it's copied into USR, local Tomcat and all, right? But that need not be done. That's for our learning, correct?
Yeah. And for logs and all, we should log into the pods, right?
No, kubectl logs pod name.
Okay.
You will log in for your learning purpose or for some testing something manually. Like we tested, okay, where file is copied or not. I want to see, I logged into that container. Similarly, if you want to test something, you can log into the pod. Like I said, You will never deal or you will never handle the individual pods. Like maybe if anyone is under impression, you will log into pod, install something, you will not do that. Unless it's your manual testing. Let's like if it's like a component testing. If you want to test something from your end, you can do that.
Priti, I think Guru's point is applicable during the auto scaling, right? Because when we do auto scaling, if one pod gets filled, terminated, then again new pod will be creating, and if it is not, then again it will create a new pod, right? I think that will be applicable during auto scaling, but
Which
not.
is applicable? I'm sorry, which is applicable?
No, Guru is saying like, if we get pod gets failed, for example, we got a crash loop
In
backup image error.
pod is failed means pods are keep on coming up.
That is a point. Yeah,
Not
exactly.
auto scaling, right? Auto scaling is why it's not because your pod failed, another pod is starting. Auto scaling means you are having 5 pods, you want to scale them, then if you like they'll be scaled up. It's not
Okay.
because previous pod failed, new pod is coming. Auto scaling is there are 5 pods running. If they couldn't accommodate the load, new pods will be coming up. That is auto scaling. What you are talking about is resiliency. Like let's say a pod failed, another pod comes up. That's a resiliency. How quickly a pod is coming up and taking this place. These are all different things.
Yeah,
Okay.
my point is not that.
Hmm.
I mean, I will set
Yeah,
records.
I understand,
I
but
got my
that's not auto scaling. Also, whenever your pod fails, let's say this Nginx, some mistake is there here. Okay, let me just do one thing. Okay, I got this. Oh, sorry. We are working as EC2 user, right? Okay. If I exit, I would end up as EC2 user. Okay, let's say this image is made with some mistake. Okay, or else I'll use something like this, which is not available definitely. Okay, I have got this pod. Okay, I will apply the manifest file again. Actually, all of this comes under rolling updates, but as you guys are having some question, let me quickly spin up this. That's okay. See, this is just a warning. Ignore it. Just come here. It's configured, right? Means it's updated with the new image.
kubectl.
Do you see? It failed, but is it starting another one? Image pullback off is again a very common error and important from the interview perspective. Like this image is not available and pod cannot be brought up.
Yeah, in this case, it's right pretty, but my question is something different. I mean, I will dig into later because that requires some more exposure for everyone. So,
Yeah.
because
Yeah.
my concept is different. I mean, like,
Yeah, Guru, I got it. We'll come to that. I'm just showing you. I just want to clarify. If your pod is failed, right, because of some error in your image or because if an image is incorrect, it will not spin up here. Okay, automatically it will not because it's something with your image. It's not with your deployment. Let's say like Nginx pod is this. This is how it is. Suppose if you have configured it in a deployment object where it provides high availability and resilience. Then if a pod goes away, it will come up. In this case also it will come up, but the status will be the same. Anyway, that's a long way to go. We'll come to those things later. Just understand creating a simple pod and checking the pod details. Okay, see image pull back off, then crash loop back off. Right? Even though you put auto scaling here, because it failed, it would not spin up. We'll take them one by one, okay? At this point, then describe if your image is incorrect. See here, this is first initially it started, right? Later on, like image pull back off. Nginx 11, it cannot pull back off. It is clearly telling you error response from D1. This manifest unknown means image not available. Error image pull back off restarting materials. Sometimes what happens if there is any incorrect image name there or else image is removed from your registries, it's gone, but it's trying to pull this, you will see this. generally in real time. In the prod environments, you will see this sometimes. Actually, on prod, you will not see, but in other environments, because there'll be some specific time or specific days where the images can be maintained on the registries. If let's say the image has been unused from any year, or else it depends on how they have designed, right? There will be some hygiene policies. If the image is not being pulled and used from an year, it might be deleted. Let's say after 1 year, if they are trying to deploy it, the image will not be available on registry. Obviously, you will see these errors, right? That pertains to the hygiene policy of the registries, how they design their repos and all. So that could be one of the use cases.
Ma'am,
Hmm.
one question. So regarding for now, how we have learned the Docker, and then now we are using the Kubernetes, and the real world scenario is where Kubernetes is utilized. Now we learned Docker the way we learned now, as in creating Docker images and then deploying them and all that. That was for the learning purpose, right? But in a real world scenario, Docker is not used when there is a Kubernetes cluster. We will be mostly dealing with a Kubernetes cluster only, right?
Kubernetes cluster is used for prod and for end user availability for providing application. But in Kubernetes, what are the things you are deploying? Images, right? Those
Right.
images should be tested. That's where Docker is used. First, you
Okay.
create an image, deploy it in your local machine through Docker run commands, test it thoroughly, store it on the registry. All of that is still needed. The pipeline still needs those steps. Build the image, push to registry, that step is there. Your pipeline still remains the same. So
Oh,
Docker is needed, right?
mhm. Because I thought then Docker would just be, I mean, mostly the Kubernetes is using its API only and will be dealing through there only. Docker explicitly is not used, I thought, seeing from
There
current
is my
scenario.
pipeline. Docker demo, right?
Docker demo is a branch. Yeah.
Yeah. So this step is still there. Without building image, how do you deploy it on a cluster, Kubernetes cluster? This still is there. Even run command should be there because you have to test it. That's why I told you this is for test or deploy in lower environments. Yes, lower
Mhm.
environments you have to deploy like this or else with a Docker compose. That is all Docker, right? This stage also will be there. First, you have to deploy in lower environments, test it first. Maybe on the same server, it could be sometimes if you want to test, or else a separate tester where you can do a quick test. If it is not Docker run, maybe Docker compose, but
Mhm.
that is to be there. Then comes the next stage of deploying into higher level environment, which might be Kubernetes cluster. Of course, higher level, when I say even test environments might be on Kubernetes, dev environments might be on Kubernetes.
Yeah,
But this quick test should be needed somewhere, right? You have to first test your container. Maybe
oh,
that testing, instead of this, you might be doing it on Kubernetes. But you should know this thing, right? Like how to test it. Let's say you want to test on your dev machine manually. Just a quick check. You have to do this, right?
right. No, I mean, this is definitely understood that we are learning the Docker. So all these tips are necessary. But in a real world scenario, they must be using, I mean, although it is a test branch or a dev branch or any branch, there will be Kubernetes cluster only because it is
Kubernetes
easier to
cluster
manage.
only. This could be also the lower environment sometimes. That's what I'm telling.
Okay.
Sometimes they might be using Docker Compose for dev and test. This is
Oh,
what we did in our startups because we don't want to put a budget of Kubernetes on everything. Our prod
okay.
clusters are EKS clusters. Startup don't have the budget of managing the Kubernetes clusters for every environment. Right? In that cases, we have a test and dev on Docker Compose.
Okay.
So you
Okay.
may have this step also. It depends on your project, your company, and so many factors. But
Right.
it's not you cannot generalize it like when you are using Kubernetes, you will not deploy Docker containers separately. No, we do. At least, let's say even dev, test, prod are all Kubernetes. Even today, I will do this in my machine manually, just a quick check because I want to test my image is working or not. before I even go to dev environment. That's out of my interest.
Mm-hmm. Okay, perfect. Thank you.
And sometimes, like in the startup, even Minikube is used as a dev environment.
Sorry,
So,
your voice was breaking suddenly
okay. Am
last
I
line.
audible now?
Yeah, this is perfect.
No, what I'm saying is sometimes even Minikube is used for dev environments in some projects, just to check, like local check, first initial step of checking.
Mm-hmm. All right, perfect. Got it.
Sometimes, yeah, like you said, they will not see even this build also. Why? Because already images might be built and active development is not there on such applications. No active development, right? Already
Mm-hmm.
images are there, no active development, images are there. So you will not have this build step at all, this test step. You don't need to, they are all very old legacy images. Directly deploy it onto Kubernetes clusters. That could be the case. So no general rule of as such.
Right, because job, I've seen different job descriptions. Some lay emphasis on the deployment side and
Right.
some lay
Mm,
emphasis on the CI side. So
right.
the tools we will
Yeah.
deal with will change.
Correct, correct. Tool stages, they vary. It's not mandatory you should have build stage before you deploy. Like I told you, right? It might be already there, legacy ones, no active development. So no actively whenever commit is made, image need not be built because commits are not at all there. So it might be just about deployment directly on Kubernetes cluster. So you will not see these stages at all, right? Even you don't with this stages. So also sometimes build might be there. This might be directly on Kubernetes. So it all depends on the design, the project, the particular use cases and requirements. Here
Right.
I'm showing from the scratch. There could be a lot of differences, but if you understand this thoroughly, those tweaks, changes, you can follow very easily.
Yes, yes, definitely. Thank you.
So, pretty like see in Docker, we will Docker file will create image, we'll build that, and we'll run container will create, and using Docker compose file in Docker Swarm, we will deploy that application also. But instead of that, we are using this Kubernetes, right? Creating the clusters and deploying the container application.
Right. Like just now I told you, like this is general correction. It could be instead of that, or it could be in addition to that in the next environment. So it could be anything depending on the use cases and the pipeline designs.
Okay, okay.
Like I just now told you, right? They might be deploying in lower environments with Swarm or a Compose. Next environment might be on Kubernetes, or else every environment might be on Kubernetes. So it could be anyway.
Okay, okay, yeah. Uh,
So that is all for today, creating the pod and all. Tomorrow we'll deep dive into the many other interesting concepts of resiliency, high availability and all. Okay, there is a question from Ramprasad. In notes, only flannel network deployment file is available. Can you share the deployment link? Sure. What I'll do is in some time, I'll update the documents here in the Google Drive. Okay.
One more concern, actually, these Docker lab assignments, we have only till fourth Docker only. The other Docker in the lab assignments, if you go to lab assignments,
Okay.
we have only till Docker 4, Docker 5, and that is not available. But in the drive, we have only the scripts and everything. That's it, whatever I seen. Yeah, if you go to Docker.
These are the documents which are the latest ones, like with all the updates and modifications. These are all available here. We'll keep updating those lab assignments. Okay. Meanwhile, you can use this one. I'll update the document here. Next
Because
step here.
yeah, because lab assignments was that was very clear, and we are each and every line will be there, right? So it is making us to practice very good. So that